Okay, let's finally take a look at some double angles. So let's go for, in the notes, I've written them off to the right, the actual identities, but when I do it on video, because I'm not going to go through all the same ones, I'm actually going to write it above. So the question at the top left says 4 sine 6x. I'm going to write that better. 4 sine 6x. And I'm going to wonder what that's equal to. So I'm going to look all over my formula sheet, and I'm going to look and see that it looks mostly like the sine 2x one. So directly above, I'm going to write that identity. I'm going to write it in that form. So it's on the left-hand side as the sine of the double without the cos, so I'm going to put it on the left-hand side. But sometimes we want to reverse that. Sine 2x equals 2 sine x cos x. And I'm going to put a box around that because it's a formula and I want to be able to quickly scan my notes when I'm rereading them for unit tests and final exams. And what's the number in front on the left of the formula? Well, I have a 1 in front. And how do I get from a 1 to a 2? Well, I'm going to double the number in front. And in the English instructions, you can see that English instruction. Double the number in front. So what's my number in front? Well, my number is a 4. So what am I going to do? Well, I'm going to make it an 8. Double the number in front. Now, on my angle, I sine angles, so my angle is 2x. And that angle turned into be x. So that means that I must have to get from 2x to x, which means that I must half it. So I half the angle, and that's in the English instructions, so I'm not going to write it down, but we're going to half the angle. So sine, my angle off to the left was 6x, so if I half that, I get 3x. And I'm going to circle my final answer. Excuse me, and we have to add a cosine x on cosine of that same half angle, cosine of 3x. So once again, double the number in front and half the angle and add a cosine. And it has to look exactly like the pattern from above. So there's 4 different examples of that. Let's go back in the opposite direction. What if the picture says 8 sine 3x cos 3x? Well, that looks exactly like the question that we just did, or its answer. But we're doing it differently. So if we see on our formula sheet that this kind of looks like the right-hand side of the same identity that's written above in the red rectangle, and we go, that looks more like the right-hand side. Well, then I'm going to write it in that fashion. I'm going to write the right-hand side first. 2 sine x cos x equals, I should align that up better, the left-hand side of the formula, sine 2x. And I'm going to put a 1 in front. So what happened? Well, I'm going to half the number in front, and I used to have a number in front of 8, and if I half the number in front, I get 4. And I learned from before that if I reverse the process, now I'm going to have to double the angle in my old angle. Excuse me, gosh, 3x, the same thing as above. Excuse me, it's been a long day. So, double the angle, 4 sine 6x. And that, I'm going to circle, and notice that was the same thing that we started as. So we need to go back and forth. But the point of that is above I did the formula that way. But this time below, I'm outlining in red. Sometimes I want to do the formula that way. And put the right-hand side from the formula sheet on the left-hand side because that's what I'm working with. And it helps me make sure I don't make any silly mistakes. So, let's take a look at another example. Cos 4x. Well, cos 4x has a bunch. Cos 2x has 3 options. And off to the right, I've written those 3 options. But I'm not going to continue to write all of the definitions and everything all over the page all the time. Look at the notes, see what it says, decide on what goes where. So, I lied. I'm going to write the first line of it. So we know that cosine 2x is equal to cos squared x minus sine squared x. And move that back over a little bit. So I know that cos 4x off to the left, I'm going to have to write a little bit smaller, will equal, well, back to the right, I'm going to put a red box around that formula. And I know that if I have cos 2x, well, all I do is half this, and the pattern continues. So I'm going to move this cos 4x off to the left a little bit. I'm going to shrink up this formula. I've been writing too big. It's difficult. Page layout and everything. Always be thinking about page layout. So remember, all I'm going to do is half the angle and the pattern follows. So I have cos squared of half of 2x, half of 4x is 2x, minus sine squared, and half of 4x is 2x. And that's my answer. That's simplified. Why would I want to do that? Maybe it's a nice differences of square that's useful for some reason. Now there's a whole bunch more examples down below about how to use the different 3 options for cos 2 theta. Feel free to check them out. But definitely read through the notes and be able to understand each individual step and go, what happened there? Why did that happen? What was substituted there? What mathematical operation was done there? We're just going to do one more. So down below we have 4 cos squared 5. 4 cos squared 5. Now what's that? Well, it's obviously a radian angle. Who cares? Minus 2 equals. And what does that equal? Well, I know my identities. Oh gosh, I'll write it again. Fine. But your teachers are going to get lazy and go, look at your identity sheet. What's cos 2x equal to? Well, it kind of looks like the 2 cos squared x minus 1, at least, the question that we're working on the left. But I need to have that 1, so I have to remove a greatest common factor. So I can take out a 2, and I get 2 cos squared 5 minus 1, and now I'm going to put a rectangle around the identity off to the right. Now I have my identity, so I'm going to leave the 2 out in front. I'm going to put the brackets just for substitution processes. And remember, it's called double angle identities. But as we went before, we halved the, well, we've doubled the angle and half the angle with sine, and before we've only halved the angle with cosine. But now we're going in the opposite direction. So back to the formula off to the right. Now we're taking x and getting 2x. We're doubling it. And what we're cosing above is 5, so it's just simply cos 10. 2 cos 2 times 5, 2 times 5, or simply 2 cos 10. And that's a valid answer. Feel free to type that in your calculator, and definitely check out some more examples down below. Okay, 6.6 proofs with double angles. Let's take a look. You can keep in mind it's in the notes, so if I skip any steps or you want to, feel free to look back at them. But 10x equals, I usually write in the center. It's off to the left because I haven't worked on it in a while. Sine 2x over 1 plus cos 2x. 1 plus cos 2x. And I really should have been more careful with those lines. We really have to be careful putting the lines on the graph paper. So on the left-hand side, some people say you can't, but you're allowed. Work on it. Turn into sine x over cos x. Know what you're shooting for, or I'll show you a trick how to reverse the process. Now, we have a fraction on the right, so I'm going to start off on the top, because sine 2x, I'm going to circle the top, sine 2x only has one option. Take a look at your formula sheet, or earlier in the videos, how we expanded and compressed this thing. Well, this is 2 sine x cos x, replacing sine 2x with its definition. Now on the bottom, I have 3 options for cosine x, so I'm going to start with the 1 plus, and I'm going to substitute with brackets, and I'm going to make them huge. Now I need to decide on which of the cos 2x's I should take out. And if you haven't gotten your formula sheet out and you're pointing to all 3 and you're not thinking about it, you're never going to do well in math. You want to be interested, you want to get ahead, you want to think, have the formula sheet out all the time, highlight it. Put smiley faces beside the formulas that you're better with, that you haven't memorized with. Go over with friends. Have you memorized all the formulas yet? Which ones have you? Let's go over the ones we haven't. But because I know I have a plus sign, when I distribute a plus sign into these brackets, I'm going to want something with a -1 so I can combine it with the other +1. As seen in the formula sheet, in the middle square, all of the instructions as to why to choose the cos 2 theta. Choose the cos 2 theta to cross off the 1, or factor, or combine with the sine squared, etc. So I'm going to choose the cos 2 theta. I'm going to circle it again from above, and I'm going to choose the definition 2 cos squared x minus 1. So again, I have my fraction, and on the top, I simply still have 2 sine x cos x. I should have done the lazy ... thing. And now above, I'm going to distribute a positive sign in, and we get 1 plus 2 cos squared x minus 1. Now these 1's cross off. And look what I have here. So I'm going to skip a line again. 2 sine x cos x over now simply just 2 cos squared x, which means not to be confused with cos 2x. It looks like cos 2x. I'm going to make that exponent a little bit smaller, but it's difficult with such small fractions, and it's going to be difficult on mobile to see. But be careful. Now I can cross off the squared from the bottom and the cos from the top and the 2 from the top and the bottom, and then I can simplify it to be sine x over cos x, and then check mark or QED or whatever background you're from. Making the left-hand side equal to the right-hand side. We went over proofs earlier in this chapter, making the left-hand side equal to the right-hand side. Working with fractions, adding and subtracting fractions and factoring. Then we introduce the double angle identities more thoroughly so you have a better idea of what we're substituting and why.